Okay, so now I will be talking about computer programming. First question is why computer programming is required. So as you all know that computer is a digital electronic device. What do you mean by digital electronic device? Digital electronic devices are the devices which actually works on only two voltage levels, either 0 or 1. And in contrast, analog uh, electronic devices are those where we have to deal with continuum of voltages. So voltage may vary from 0 to say plus 5 volt or plus 12 volt in continuum of the values. So computers or all modern digital devices are the devices which works only on two voltage levels, either 0 or 1. So it is because of this thing that we need to program our computer, because working in zeros and ones demands us to be able to tell computer that what tasks to perform and how to perform them, and that is done with the help of computer programs. So it's like transforming from one language to other language. The language which we know are usually English, Hindi, or our respective languages, and the language which computer understand is just the language of zeros and ones. And therefore we need a computer program which can take up instructions from analog world, the world in which we understand instructions, and transform them to the instructions in digital world, that is the instructions in zeros and ones, and those instructions then can be processed with computer hardware. The computer hardware is designed in such a way that it can understand only the zeros and ones. As I told, the voltage levels are either low or high, like that. So for that we need to program our computer. So that's what is done with the help of a computer program. As a simple example, uh, now you all are using mobile phones, smart mobile phones, and say for example I'm recording my voice in my smartphone, mobile phone. So all those mobile phones are also nowadays digital devices. So the voice which I am producing or recording is being recorded in the mobile phone or in a computer microphone in the form of zeros and ones. So that is actually done with the help of some computer software which comes in the form of various voice recorders. So they take the human voice or any other voice in the form of analog signal, and then converts it with the help of analog to digital converter, and those digital converters gives that digital data which is in the form of zeros and ones, and that data then is stored in the uh, digital storage devices in the form of zeros and ones. So that is one example of a computer program. And then the computer actually processes those zeros and ones in with the help of its hardware, and the output which we desire from computer should be in the form of uh, uh, analog world, because we cannot understand that complicated language of zeros and ones. So for example, I have recorded my voice in the computer, and if computer gives me that output in the form of zeros and one, that doesn't make any sense or meaning for me. Therefore I prefer that in whatever format I have recorded my voice, it should come back to me in the same format so that I can listen it at some later stage. So that is also done with the help of some computer program which uh, takes those instructions from computer in the form of zeros and ones and converts them to the outputs which are desired by the analog world, the external world. So therefore, that is what is done with the help of computer programming. So there are different types of computer languages, programming languages, low-level languages and high-level languages. There are some sort of languages which are called middle-level languages. Low-level languages are actually the languages which are nearest to the hardware. I mean, those people who are working in hardware designing, they usually work in terms of low-level languages. They have to work in zeros and ones, say programming of a microprocessor, that can be seen as sort of low-level language. And the languages, programming languages which usually people use are high-level languages. They are sort of application level languages. So they are high-level languages and they are simple to understand. Low-level languages require expertise of hardware as well as software. But high-level languages just require expertise of software. You don't need to go deep into how the hardware is working and so on. Anyway, we are not going into details of that. So let's move further to high-level languages. So there are two categories of high-level languages. One are compiler-based, other are interpreter-based. And anyway, low-level languages are machine language, assembly language. I'm not going to that right now. Compilers, what is a compiler and what is an interpreter? So compiler is a technique in which a program written in high-level language is compiled in a single go, and then that executable which is formed as a result of compilation of a program is run later on. Means what is done with the in a compiler is that a full program is compiled and converted into an instruction set which can be executed by the computer. Again, that is done. So means the set of instructions is converted into machine language in some way with the help of a compiler, and then that machine language is read by the microprocessor of your computer, and the desired set of instructions are performed. And in interpreter based, what is done is that every line of the program is executed, and then the program is executed line wise. So first line is executed, then second line is executed, and at the same time it is converted into machine language and so on. So well, let's now talk of components of a computer program. What do we mean by components of a computer program? Is that okay, what are the essential parts of a computer program? So as I already told, that computer is a device which actually understands information in the form of zeros and ones only. So we need some set of input statements in a computer program, which can be some numbers, which can be some characters, which can be some signals like a voltage signal from some sensor or from digital to analog converter, etc., etc. So a computer program should have some sort of input statements which user can define easily in his simple language, and then those input statements can convert the data entered by user into zeros and ones, which is then read and processed by the computer. And for that, again, computer program will have some instruction sets which will process that data as per desired instructions, and then that program should give us some output, which again can be in the form of numbers, characters, signal means voltage signal, right? A simple example of say computer based amplifier, say it may have some microphone which takes some signal as an input, then converts it into zeros and ones, and that is processed to some amplifier to some output, and then that signal is further given in the form of output in some speakers, for example. So ultimately data, analog data is being converted to zeros and ones. It may be recorded or whatever is desired as per program, and then that same data is fed out to the different output devices. It can be speaker or any other thing. So these are some basic components of a computer program. Now our main objective is to actually learn Fortran programming, so I will be focusing more on computer programming, and that is Fortran. This language is used by scientists for their scientific programming. So Fortran stands for formula translation. So let's talk of more of practice now rather than going into theory. So I will first talk about input output statements. So I mean, how can we input some data in a Fortran program, and how can we get output from such a program? So I will first talk of a very simple statement, which is print command in a Fortran program, and I will be illustrating these simple forms of print command. First is print star comma hello world. This is a very standard thing which we do in any programming language. What is the meaning of this is, print means it is an instruction in Fortran. Star means where to print. So this actually represents the format of the output, how output will be printed. Okay, sorry, this star represents the display unit where to print. So star means by default, which is your screen. Print star means print something on screen, and what to print. Comma is this is just syntax. So print, this is unit name, comma. So by default we usually use star. So I will illustrate later on what can be other options for this. Now anything written in quotes, any text written in the quotes will be printed on screen as such. So if I give command in a Fortran program, print star comma anything in quotes, that will be printed on the screen as such. So let me illustrate this simple command first in command line. So okay, let us make a simple program, say p1.f. I will be using gedit because most people should be comfortable with this. Let me make a computer program called p1.f. So I'm not using this one. Let me say print star comma say hello world. Okay, this is standard thing. I mean, if you have to this, if the at the end of a program we have to type stop end in Fortran. So that's, I made a simple program first. This is called a source file, right? Then I have to compile this, and the way to compile gfortran program in Linux is gfortran. This is the compiler. As I told you what is a compiler. So gfortran is a compiler space, this is the command. How can we compile? Say p1.f. So this is the Fortran file which we have to compile. So just that's all we need to do and enter. So if everything is fine, there is no syntax error or any other thing, then it will successfully compile the program. And now what you should see is a file named a.out. So the file which is seen in this green color are called executable files in Linux. Means those are some binary files which can be read by the microprocessor, and it can execute the instructions written in those files. So let us execute. How to run that file, how to execute run an executable file is dot slash, this is forward slash, and the name of executable file, so a.out. So you remember what was our program? Hello world. So anything written in the quotes shall be printed on the screen. So print star. So that star means to print on the screen. So I will be currently focusing on the print messages which are to be printed on the screen. Second is, say, let us try another simple program, print star comma 5. So let's go back to the program. I just opened it up. let us make the same thing. Okay, let's keep this line and add a fresh line, print star. So see, any instruction in, if you are making a .f file, so any instruction in Fortran shall be shown in a changed color, right? So if there is some garbad, or if there is some error, say instead of n, suppose I write m, then that color won't be changed. So you should be a little cautious that there is some syntax error, right? Anyway, print star comma say 5. Let us write on this. Let's see what our Fortran program do. So 5 is a constant, Fortran constant. I will be showing it in my coming video. That okay, what is this Fortran constant? But anyway, let us see what it does right now. So if you make any changes in source file, that is this file .f file, we must compile the program before running it, because if I run it without compiling, it will show only the previous things which are written in the compiled a.out file. So I will have to compile it. So g fortran p1.f means no syntax error, everything fine. So /. So what did this do? First line just printed hello world, whatever was written in the quotes, and then second line just printed out this. Let us see another example. Say suppose I want to print this is a real number, so I have to go back to my input file. Let us add a new line, print star comma say 2.80, save it, close it. Now as you know what we have to do, we have to compile it, everything fine, ./a.out. So that's how it is doing. Now see, what we had entered is 2.80, but what computer printed is 2.7999995. It is close to 2.80 as you can see, but it is not exactly 2.80. This is something which is because of round off errors in the computer. I mean, this is not even round off, this is because of conversion of this one our numbers to the binary form, and then our computer has a fixed bit size, and whatever accuracy is there, it can store only that many digits, and that is why this thing happens. But anyway, we will talk about this in some later videos. So we are right now just talking of print statement, so I won't be making it more complicated. So it is fine, 2.80. Let's use another print command in some other way. Say let us try to print 3 plus 8. This is an expression actually, right? So let us see what it does. Open, say put another print star comma 3 plus 8, right? Let's see what the program does. So I saved it. Let me close this. Again compile it. So anything you write with exclamation mark, say GFO. So what it will do, it will recall previous command which was given with these initial words. So this was the previous command. So I don't need to type whole command. Anyway, that's a shortcut. So ./a.out. So that's it. So now see, there is no error here because these are integer constants. This is a real constant. I will be talking about what are real and integer constants in my coming lecture. So you must follow my coming lectures. So there is no error here. This is why, because integers can be stored in in an easy manner. That is why there is no much error in them, and we have to be careful while dealing with this real numbers. Anyway, print statement, say this command. For this command I need to be little careful, but okay, let me first try this as such. So I am using something like a, and then I want to do this. So this first part will do, this will type this message as such, and then value of a. So let us see what it does. Where is my, okay, I have to first open that. So gedit this one, yes, say print star comma the value of a is equal to comma a, right? So let us see what it does. This probably will be interesting. So let me compile it. It's compiled, so no problem. Now a. Now question is, from where computer picked this value, right? The question is, from where computer picked this value. You should be really be asking this question anyway. But before this even, let me try another thing. Let us define something, some more number. Instead of a, let me say b. Okay, I'm keeping it secret right now, but it will be clear to you very shortly why I'm doing this. So let me compile it. G Fortran, that's compiled. B again 0. So computer, from where computer picks this value? I should for this know read command. Just a minute. I hope it's yeah, here. Well, read command. So what read command does is read star comma a. So basically a here is a variable name. It basically refers to a memory location which I have named a in computer, where whatever I store, I want to store during execution of the program. It will be read from the keyboard. Read star means read from the user whatever he types in keyboard. Star refers to keyboard here, the default input unit. And a means it is some memory location. So whatever user enters through keyboard during execution of the program, that will be read in and stored in a memory location named a. We can later on access that memory location with the help of print command. Whatever has been stored in a, that will be printed this way. So let us try this. Let's go back to the program. Let me open the program. Yes, and let's try it here. So we are using b, so let me say read. So you must have noticed that change in color of read word. Say b, right? So let us see how the program behaves. I am coming here. Let me compile it. G Fortran. So it is compiled. Let us run now. Now let's come here. What is happening? First instruction, print. So computer did this. Second instruction, print this. Computer did this. Third instruction, this. Computer did this. Fourth instruction, this. Computer did this. 11. Now fifth instruction is read instruction. So you will be seeing a cursor blinking here. Means it is waiting for the input from user, whatever I will enter in keyboard. Let me say 65, right? And I press enter. Now that's what is happening. So that's B, means next instruction was read. Unless user enters some number, program won't go beyond this. So if you enter the number and then press enter, then it will go for the next instruction. Star comma whatever is the text, it can be anything. I mean, it's not mandatorily this value of b. So this value is now coming from this memory location, a memory location namely b. User have stored a value 65 in that memory location, and that is what is printed. Now that is where my that previous question was. Now that is how my previous question now here is answered, that whenever we had not defined anything in b, it was typing by default 000, right? So if we have not defined anything in a memory location and we are using it, there are chances that the value of that particular data from that memory location will be taken 000. So you must be careful. Whenever you are using any variable in your program, you must define its value before using it carefully. If you are using a variable but it has not been defined somewhere, it may lead to serious errors, and that won't be told by computer that okay, you are not defining the value. It will take some default value, whatever it may be 0, and that can lead to some unforeseen errors, right? So that's what you should be careful about. I think that's one command. Say that's if you have to read a single variable. Now you can, by using same read command, read two different variables. Let us try that. Let's come here. So read say a comma b, and let me try this. Read say value of a first. So let me write a here, and second one is this one. Okay, let me copy the whole line and paste it. You should have noticed that I am typing everything after certain columns. I'm using tab key. That's what is required in a Fortran program. So first few columns are reserved for something. What is that something? I will be sharing in my coming videos. So anyway, so I'm not talking about that right now. So let us stick to what we are doing. A and B. Let us see what is it doing now, right? So we have to first compile it. So I'm using arrow keys. Previous commands can be recalled from up and down arrow keys. Well, so it's compiled. Let us run it. Again, same thing. I have closed the program. Okay, don't worry. Let me open it in a new terminal. Gedit say p1.f. Let's try to understand the program. So this is first line, second line, third line, as I already explained that well, these are executed. Then it is waiting for what values of a and b. So how they are defined? Let me say a is 54. Now again, in previous case when I had entered 65, it had went to next line, but now here it is waiting for values of two variables a and b, right? So now it is waiting. It has taken first value, stored a in that memory location, and then it is waiting for the value of b. So we have to enter that. Say suppose this. So now that's what has happened, correct? So I hope read and this print statements are clear to you. You try these simple programs, read a, I, j, and then try to see this. With this, I will end this video. I hope you are now okay with the read and print statement. If there are any doubts, you can ask me in the comment section, and keep following me. You can subscribe this channel for my upcoming video on these Fortran constants and Fortran variables. So with this, thank you very much.